All right, let's talk about something that's at the heart of pretty much every application we build. How in the world does our Python code actually talk to a database?
Have you ever stopped to wonder about that? When you log into a website, toss a few things in your shopping cart, or smash your old high score in a game, how does that information stick around? It's not magic, right? The app has to save it somewhere so it's there next time. But how?
Well, the simple answer, of course, is a database. It's like the long-term memory for our applications. But for us, the developers, the really interesting question is, how do we build the bridge between our Python code and that memory?
As it turns out, it really boils down to two main ways of thinking about it. First, there's what I call the direct approach. You roll up your sleeves, you learn the database's native language, which is usually SQL, and you speak to it directly. Or you can use the translator approach. You just keep speaking Python, your native language, and you hire a special tool to do all the translation for you. Let's break down what that really means.
Okay, first up, the direct approach. This is all built on a super important standard called the Python DBAPI. And you have to understand, before this thing came along, connecting to databases was the Wild West. Every single database, MySQL, Oracle, you name it, had its own weird, unique way of doing things. Your code was a tangled mess, and switching databases was a complete nightmare. The DBAPI, well, it brought some much-needed order to all that chaos. So what is it exactly? The DBAPI, which you'll also see called PEP 249, isn't a piece of code you install. Think of it more like a rulebook. It's a specification that says, hey, if you're going to write a Python library to talk to a database like SQLite or Postgres, you have to follow these rules. You have to provide these exact functions with these names. And why is that so brilliant? It means we can write our code one way, and it will work with tons of different databases with just tiny changes. It's all about portability.
And the process it lays out is so logical. It's always the same 5-step dance. First, you connect. Then, you create what's called a cursor. The best way to think of a cursor is like a little messenger. You give it your commands, it runs over to the database, and it brings back the results. After you have your messenger, you execute your SQL queries, you commit, which is just a fancy way of saying save my changes for real, and finally, you close the connection. That's it. 5 steps every time.
Now, theory is one thing, but what does this actually look like in real life? Let's take a look using SQLite 3, which is awesome because it's a database library that comes built right into Python, and it follows that DBAPI standard perfectly. See, this code maps perfectly to those 5 steps. We use SQLite3.connect to open the door to our database. Then con.cursor gets our little messenger ready to go. Now look at that execute line. This is the absolute key. We are literally writing a raw SQL command as a string in Python and handing it to the messenger to deliver. No translation, just direct communication. Then we commit to make it permanent and close to say goodbye. It's clean, it's direct, and it's incredibly powerful.
So if you remember one thing about the DBAPI, let it be this. You are the one speaking SQL. It gives you total, precise control over the database. But there's a catch. You have to be fluent in SQL to do it.
But what if you don't want to be writing SQL strings all day? I mean, what if you'd rather just stay in that comfortable, object-oriented world of Python? Well, that's where our translator approach comes into play, and it's all powered by a kind of tool called an ORM.
That tool is an Object Relational Mapper, or ORM for short. An ORM is that professional translator we were talking about. It's this amazing bridge that lets you think about your database like it's just another collection of Python objects. It cleverly maps your database tables to Python classes, and it maps the rows inside those tables to instances of those classes. You just speak Python, and the ORM worries about all the messy SQL translation behind the scenes. And this slide right here, this is where it all just clicks. Look at the difference. On the left, with the DBAPI, you're writing a raw SQL string to create a table. It works, but it's SQL. On the right, using an ORM like SQL Alchemy, what do? You define a Python class. You describe what a student looks like using pure Python code. And then the ORM looks at that class and goes, I see. You want a table named students with these columns. I'll go generate the correct SQL for you. It's a totally different philosophy.
And this isn't some weird, obscure concept. It's an incredibly popular and mature way of working in the Python world. Huge, powerful libraries like SQL Alchemy, the Django ORM that powers so many websites, and Peewee, they're all fantastic ORMs that provide this translator service. So now we have these two amazing options. We've got the direct, raw control of the DB API, and we have the Python native convenience of an ORM. The important thing to realize is that this isn't about which one is better. It's about understanding the trade-offs so you can pick the right tool for your specific job.
And this table really lays it out. On the one hand, ORMs can mean much faster development because you're just writing Python, not tons of SQL. They make switching databases easier, and this is a big one, they can dramatically reduce security risks like SQL injection because the ORM is handling how your data gets put into the query safely. But there's no free lunch, right? That translation layer can add a tiny bit of performance overhead. And if you have a really complex query you need to run, sometimes it's trickier to express that through the ORM than just writing the SQL yourself.
It really all boils down to this single idea. The DB API gives you raw, unadulterated power and control. And ORM gives you simplicity, speed of development, and the comfort of staying in Python. Power versus simplicity. That's the fundamental trade-off.
So now that we know all this, how do you actually decide? You're starting a new project tomorrow. Which path do you take?
Let's just cut right to the chase. You've got a new project on your plate. It needs a database. Which tool do you reach for?
Here's a pretty good rule of thumb. You should reach for the DB API when every single microsecond of performance is critical, or when you know you need to write some crazy, highly optimized SQL query that an ORM might just get in the way of. It's also perfect for quick, simple, one-off scripts. On the other hand, you should probably reach for an ORM when you're building a larger application, where getting things done quickly and making the code easy to maintain is the top priority. And if there's even a small chance you might want to switch from, say, SQLite to Postgres down the road, an ORM is going to make your life so much easier.
So ultimately, the choice is yours. There's no single right answer, just the right tool for the job you have in front of you. So the next time you start a project, just ask yourself this. Am I going to be the SQL architect with my hands directly on the controls? Or am I going to be the object master, working at a higher level with the speed and power of Python?